This is my ColecoVision compatible computer. It's the first revision of the system board, and there's an AV board over here as well, and there's a small little board over here for the actual cartridge slot. But it's at a position where I can actually, like I say, run actual ColecoVision cartridges. So at this point of the actual development, I'm going to run an actual ColecoVision cartridge which I purchased when I started off this project. I looked online for the cheapest one I could get, and it was Donkey Kong. I think it's because it's a cartridge which came with the actual original ColecoVision system, and so there's apparently loads of these out there. So I think it was only about 15, maybe £20 that it cost me for that ColecoVision cartridge. It's the only ColecoVision cartridge I got, but I wanted to be able to verify it could actually run official ColecoVision cartridges. And then I've got my own multi-game cartridge which I want to actually run as well. So the whole point of this at this point is to actually test my multi-game cartridge and verify that it works okay. And it's a very basic cartridge. There's no special electronics on it at all. The selection of the game is done by a rotary switch at the top, so I can select up to 12 games, and the selection is all done by diodes. And so I've got 4 ROMs, because I've got loads of these 64K EEPROMs from years ago. It was a good reason to use these for this particular project. And I've got 4 games on these bottom 2 ROMs, so 64K divided by 4 is 16K, up to 16K per game on these, and then 2 games on the top 2 ROMs, so up to 32K games on the top 2 ROMs. So when I run these games, you'll see that there's still some work that I need to do on the actual system itself. So the AV board, it encodes the colour for the PAL composite video, and that needs some work on it still to be done, so it's not given correct colours yet. It also has an audio amplifier on there, and you can hear some noise, and the noise I think is coming from this oscillator over here, which is for the video system. And the video system, because I had to do that off board, and it's on one of these Vera boards, or breadboards I should say, and these aren't particularly good for actually running electronics on particularly, and I've got all these little wires running to and from this board, and it runs at about 10 megahertz, and so that in itself, that setup is I think causing me noise, and you'll see the noise on the display as well. It shows up on the graphics. So actually, before I actually try and correct that noise, if it's maybe it's something else on the board, I need to actually make a second revision of this system board where everything's on the system board, so I can rule out all of this extra electronics from being the cause of the noise. Okay, so I've turned my flashlight off for this part of the video so that hopefully you should be able to see what comes up on the display a bit clearer. It doesn't show up very well on the camera because it's only a small display, and like I say, the colours aren't correct yet on the system itself. But the first thing I'll do is I'll plug in the Donkey Kong, the official cartridge, ColecoVision cartridge. Just locate it. Okay, so when I switch it on, the camera just adjusts to the brightness of the video, and so it fades in. As you can see, you can see the noise that's coming up there. You can hear it through the internal speaker as well. And these title screens, they take about 10 seconds, and then it goes into the game, and you can see the noise. But you can see the game's playing, and you can hear the actual sound coming through the little speaker. But you can also hear the noise, and it's the same kind of high pitched. Now it's you've got this kind of noise. It's a much more high pitched noise. But at least I know that the actual audio chip works. I know that the CPU is working, the memory is working, the ROM, the BIOS ROM is working. I know the display is working. I've just got this noise and the colours do, and also the controllers. I haven't plugged in the controllers yet. So what I want to do next, but hopefully before I get a second revision of this board, if I can get the controls working so that I can actually play games, then I'll know that it's basically a good ColecoVision system. But I just need to do these little minor cleanup things, and ultimately, like I described at the start of the video, it's actually going to be a ColecoVision compatible computer. So I've got a little socket over here where I can plug a keyboard into, and actually you should be able to run other things, and I'm hoping to be able to run ZX81 games on here as well as ColecoVision games. Also across to my left, I've got like an external amplifier, and I can actually switch off the internal speaker. There's like I put a little button switch on there, so I can turn off the internal speaker. I'll just power up my external speaker. and that gives much better audio quality, which I'll leave plugged in for the rest of this video, and you don't hear the noise so much on that speaker either. So I'll switch off now the actual Donkey Kong cartridge. So I'll plug in my multi-game cartridge now. And when I switch on, there'll be the noise, and it's actually on game 2. Let's switch to game 1 first of all and hit reset. So it starts off with the Atari logo, and it's the Pac-Man cartridge. So it plays the Pac-Man one, and it goes to the next screen, and it gives you the selection stuff. But again, the noise makes it all a bit funny. So switch to game 2 and hit reset, and it's gyrus, and so all these seem to work okay. I'll go through all of them. There's 12 games that you can select, and this one is Gorf, and it'll start up after about 10 seconds or so. So that screen displays quite clearly, and it automatically starts on this particular game because there's no controllers plugged in yet, and I think I need to correct something on the controller stuff. It's automatically pressing one of the start keys, so you can see it actually plays the games as well on this particular game. I'll go on to the next game, and this is Frogger. So you can see it plays quite well, but all the colours are really terrible. You can tell the colours are terrible on this particular game. So I'll go to the next one. I think I think there's an issue with the reset as well, which causes some of the noise as well. So if I switch off and switch back on this particular game, this is Space Invaders. So this one won't start if I hit reset, but it will if I power off and power on. So I think it's to do with the rise time on the reset, so I need to sort that out. So there's about 3 or 4 issues that I know of, which I'm going to need to sort out on the next revision of the board. And the next game. So this is Time Pilot. This one actually has quite a bit of activity to it, but it shows that there's I think it's to do with the colour. The actual horizontal hold doesn't perform particularly well on this. So I think that's to do with the colour encoding. But it plays well. I'll just let it crash. Or maybe it's going to take a little while to crash. So okay, so I'll move on to the next game. Centipede, and this one just goes on to the next screen, which is the level select screen. Oh, and this is Star Wars, and again it looks more terrible because I hit the reset. It looks more terrible than if I switch off and switch on, and then you get the better graphics. So it's not just noise that's causing the issue with the actual graphics on the display. Also something to do with the reset circuit as well when I hit the reset button. And you can see that the controller's doing funny things because I don't have the controller actually set up yet. Oh, this one's Defender, so another one I have to switch off and switch on rather than hitting the reset. It doesn't do much, that one. I think, what's this one? This one's Mr. Do. I don't know really why they made it wait about 10 seconds or so on the start-up screen. Because when you think about it, the computers like Spectrum took ages to load, and that was one of the downsides of them. Whereas to make a cartridge system deliberately wait seems to be a bit counterintuitive, really. And so this one is Super Donkey Kong. So there's a Donkey Kong cartridge which I plugged in at the very start, which is the official cartridge I've got. And then there's Super Donkey Kong. Actually, I prefer the version of Super Donkey Kong because it's more like the actual arcade machine. And then there's one more game of the I think of the 12 games. Yeah, just one more. And this one's Galaxian, my favourite game in the arcade. But that works well as well. So it's a shame that there's a bit of noise, but like I say, this is all a bit dodgy circuitry around here. So it may be to do with the dodgy circuitry, just picking up a load of noise and generating a load of noise. And I've got some like little chips off on extension cables as well. And in a second, I'll just go through from right to left the things that I've updated, like these chips which are on extension cables, and talk about why I've done that and what it was to fix. But this little board off the back here, that's where I'm going to hopefully have a bit banged UART port for saving the loading things from CPM, because I'm hoping to be able to run CPM on this as well. Hoping it'd be a reasonably decent computer as well as ColecoVision console. So to start with, I've got address decoding for the memory and address decoding for the I/O system. And the I/O ports, I had to change the address decoding on that because the sound chip operates in a weird way, because the sound chip actually runs slower than the processor, so it actually has to tell the processor to wait for it occasionally, and you have to do something special with the I/O decoder, which I didn't do, and so I've had to, like on the back of the board there, I've made some modifications to that. This board I've got here where the cartridge plugs in, well eventually, like I say, it's going to be a computer, so I've got, this isn't the official keyboard, this isn't the keyboard I use for development, it's just cheap keys, whereas I've got proper keys on the actual keyboard that's going to go on here. But that should sit over the actual computer itself, and there's enough space to have the cartridge out the right hand side, so I need to move this connector, the cartridge plug-in connector, over to the right hand side of the board, so it's out of the way of the keyboard, which is going to go on top in the case. So I've got the ROM, which is just BIOS ROM at the minute. There'd be 4 BIOS ROMs on there, so I've got a two-way switch up here, so I can select up to 4 parts of this ROM. So 16K at the bottom of memory for the BIOSes. So there's going to be the ColecoVision BIOS, ZX81 BIOS, hopefully a Jupiter Ace BIOS, but I'm not sure if I'm going to be able to get that to run. I'm more confident about the ZX81, and then also a CPM BIOS as well, and so it'll bank out all the BIOS ROM and bank in a complete 64K of RAM, so the CPM can run, and hopefully I'll get a storage device connected on the back there. Got at the minute 32K RAM plugged in here, but the socket is actually longer, so it can actually take 128K RAM as well, which is what I'll need to do for the actual CPM to run. Z80 processors on the extended board, because accidentally when I placed the connector on KiCad, I selected the 42-pin connector rather than the 40-pin connector, so I wasn't paying attention for that. The sound chip for the ColecoVision is out on the extended board, because on the Texas Instrument chips, for some reason they seem to put data bus in reverse order, so D0 is actually the most significant bit and D7 is the least significant bit, and I knew about that in the past, because if you look back in my videos, I did an actual video where I manually controlled one of these chips, so I knew it on that video, but I just forgot, and when I was laying out this board I put the data bus the wrong way around, but at least I know that I've verified that works, so that's cool. And then I've got 2 controller chips for the I/O for the controllers, but they're not plugged in at the minute, which is why the controllers went a bit funny when I was playing the games, or when I wasn't playing the games, but they started okay. They've got some chips up to the middle for doing the crystal oscillator and a bit of logic to do memory selection and stuff. Then this other chip was out on the extension here. So I've got a video chip here, the Texas Instruments video chip, which, by the way, the data bus is on reverse order on here, but I remembered to do it in the reverse order for that Texas Instrument chip. I don't know why Texas Instrument did it. There must have been a good reason why they did it, looking kind of back to front kind of way for the data bus. Anyway, normally this actually takes dynamic RAMs, and you can connect 2 dynamic RAMs to it directly. But I wanted to connect a static RAM, so underneath this PCB, under the AV PCB, I've got like static RAM, and I've got 3 chips to actually communicate with that static RAM rather than it be dynamic RAMs. So I wanted to do that because dynamic RAMs are a bit harder to get hold of these days, like the old-fashioned ones. This is all supposed to be classic electronics, so there's no microcontrollers, no ASICs, no GALs, no PALs, no FPGAs. It's all traditional 80s to 90s electronics. So it's all. So I consider this a retro computer, not like a lot of the stuff that people build. They usually like give in and do something on the video or something which is out of the which isn't retro sort of thing. And then I've got an AV board that plugs on top. I did that for a reason, because I knew that the AV thing was going to be potentially going to be an issue, and I didn't want to have to remake the system board if I hadn't something which I needed to change on the AV board. And not only that, but my board is for composite video, but you could make an RGB board instead of a composite video board. And also it means I can put the little amplifier which I have for doing the internal speaker on this board as well as have the audio out and the composite video out on the board. And then finally at the front there's the timing for the video. So the actual CPU runs at 3.57 something megahertz, which is the NTSC color burst frequency. So if you want to do NTSC color encoding for the composite, I've selected it so you can select that frequency to go up onto this AV board, and you can use that directly. There's a crystal here which is 4 point something megahertz, which is the PAL color burst frequency, and so this jumper at the back is selected to take this frequency rather than the system board frequency, because I'm working in PAL. And then there's a color encoding chip here which I need to get working properly, but like I say, this frequency out oscillator out here is for the 10 point something megahertz, which is required to actually drive the display chip, and so it's a bit of a mess, and that all needs to be tidied up and going on the board, and hopefully that should clean up the noise without me having to do other stuff. But I get this feeling that it probably won't clear up the noise, and I'll probably have to find out whatever's causing that noise. So this is how the cartridge works. The actual cartridge slot for ColecoVision is actually quite small compared to a lot of cartridge slots on computers. It contains the address bus, the data bus, a ground and the 5 volts, and then there's 4 other connectors. One is enable 80, so this is address 8000 hex, so that's halfway up the memory, and then there's the select address A000, and then there's a select address C000 and select address E000. So they can have 8K ROMs in a cartridge, and they don't have to have any logic to actually select the 8K ROMs. They can just take these lines which are provided, so saving themselves electronics in the actual cartridges. So if they wanted just a 32K cartridge, they could just use the EN 8000 hex and just have the 32K cartridge there, or they could have 2 16Ks, so EN 800, and I guess it's the C00 selector they would have, or any combination of that. So the way I'm doing my selection is just using diode logic. So the ROMs are up here. So all the ROMs are 64K byte ROMs, and at the top I've got some pull-up resistors in a resistor network. I pull up certain address lines, so I'm pulling up on these ones which have the 2 selectable games, so they're 32K games times 2. I'm just having to pull up the A15 line, and the chip enable line. And all of the ROMs, the output enable goes into these diodes, and it's pulled up naturally, and the diodes just connect to the ROM selects that we were talking about earlier from the actual cartridge slot itself. So if any of the ROM selects are selected, it means that a cartridge ROM is being selected. So they're all together using diodes here. So it output enables all of the ROMs, but that doesn't mean that all of the ROMs are active at that time. It depends on which one is chip selected, and the chip select is what I use the actual multi-switch for. So the chip select on here, I only need to select on these ones where I've got two 32K ROMs inside the 64K ROM. I need to select on address 15, A15. So if A15 is pulled low on the switch and the chip enable is pulled low on the switch, then it selects the low part of the ROM. Or if just the chip enable is pulled low but the A15 is left to be pulled up, that's the high game in the ROM. And the same for the second 32K ROM. And on these other ones where you can have 4 games in one ROM, so each one up to 16K ROM per game, we use top address lines, and they're both pulled up by default. And again, using diode logic, it selects one of 4 positions for these. Either both the address lines are low, both are high, or one is low and one is high. And if any of them are selected, then so you've got 4 which enable the chip. So any one of the games is selected, chip is selected, and that goes down to this multi-switch, and the multi-switch pulls any one of them down to ground. So it selects. So if it's pulling this one down to ground, then it's pulling these items down, so A14 down and the chip enable down. And that's how the multi-game select works. So very little in the way of electronics within the actual cartridge itself, and a simple multi-way switch to select which game you want.